Welcome everyone to the third lesson of Unit 5, Topic 1, Matrices. Tonight we're just going to do a quick review on this warm-up page of what had been done last week, and then we're going to move into matrix multiplication later on. Now it's important to remember that as we're doing matrix operations, when it's addition or subtraction, 1 subtract negative 1. Okay, so each element goes with its own thing. That's going to be a little bit different from what we do later on with matrix multiplication. So it's going to be especially important to make sure that we are paying attention and getting down these notes once we move into matrix multiplication. So -2 subtract 3, notice lower left, subtract lower left. It wants to be in the same exact location. And this last one here, 5 subtract -4. And so 1 subtract -1. Anytime that I have two negatives next to each other, I make that addition. So 1 plus 1 is 2. 3 subtract 7 is -4. -2 subtract 3 is going to be -5. And 5 subtract -4. Once again, we have that double negative, so that's going to give us 9. Okay, so we're doing all these right now by hand. But in the next topic, which is in about 3 weeks, we will be wanting to use a calculator. So it's going to be important to make sure we can get our hand on one, or we can download one on our phone. It'll make our lives much easier. And when we're looking at something like this right here, remember this is a scalar matrix, so each one of these, this is being distributed to every single one of those items right there. Now for the sake of just neatness, I'm going to erase that now, but you get the idea of what's going on. So I'm just going to rewrite each of these. So half of 4 is 2, half of -8 is -4, half of 6 is 3, 1, -2, and half of 0 is still 0. Okay. I'm going to do the same thing for the second matrix. I'm going to distribute out that 3 to every single one of those terms. So 3 times 1 is 3, 3 times 5 is 15, 3 times -2, 3 times 0, times -3, and 3 times 3. Once again, just like the last time, we're going to be adding each element, upper left, upper left. Now remember, when we're doing matrix operations of addition or subtraction, we need to make sure that they're the exact same dimension. So this is, remember, we go by rows by columns. This is 1, 2, 3 rows, 1 column, 2 columns. So it's a 3 by 2. We can just take a look at the shape of it. We know that this is also 3 rows by 2 columns. Even if we don't have the vocabulary, we can see that they're the same size. My answer here is 5, 11, -3, 1, -11, and 9. Now when I'm looking at this one right here, this is a 2 by 2. Remember, rows by columns. And this is going to be rows by columns. We're going to look at, and this is going to be especially important when we do matrix multiplication in the next step. This is 2 rows, 1 row, 2 rows. So it's 2 by 1, 2, 3. Okay. They're not the exact same dimensions, so we cannot add them together. It's a dimension mismatch, and we can just say undefined. Okay, we just can't do it. Moving on to the next step. We're going to do a couple examples together. We'll do several homework assignments. And then finally, the answers will be posted online as a PDF that you can check. Okay. This is still on that warm-up page. Use what we know about matrix operation to solve for the missing variable. We're going to be doing some of this later on with matrix multiplication, so we want to make sure that we can do it with the easier operations of addition or subtraction. And when I look at where the unknown variables are, I have an unknown variable here, I have an unknown variable here. So I'm going to be solving for both x and y, but I'm just going to pick one to do before the other. Remember, when we're doing addition or subtraction, because this x is in the upper right-hand corner, I'm going to use this piece of information here. Subtract of a -1 subtract x equals 7. And this is just algebra 1 from here. I'm going to add 1 to both sides. -x equals 8. Then I'm going to multiply both sides by -1, so we get x equals negative. Now just for color purposes, so it's less confusing, I'm just going to make this y green. And so because this is in the bottom right, I know that the elements that I have to use in order to get that are going to be always in the bottom right. Get 5 subtract a -4 equals y. I have that double negative again, so I'm subtracting a negative, means I'm adding to a 9. It's going to be what y equals. So that's a review for today from the previous week. If you have some questions on that, please make sure that you talk to your teacher about it. But overall, in the Delta Math assignment, it looked like most of my students did quite well with that. Okay, so now we're going to be moving to matrix multiplication. So given that matrix A is a 2 by 2, right, 2 rows by 2 columns, okay, and this is a 2 by 2 as well, we're going to find matrix C that equals A times B. Okay. Now, when we're doing matrix operations of addition or subtraction, if we're adding, okay, the matrices is not going to make much difference as long as they're equal matrices. We can add them. Okay, the dimensions are the same. Here, it's going to be a little bit different. Now, if we were in person, we'd probably be linking the relationship between viewing each of these as a vector. And we could do that, but since we didn't really cover 4.2, we're not going to go into that definition right now. So I'm going to skip this definition right here. I'm going to skip and go into some of those examples. Notice that each entry in matrix C is the dot product of a row in matrix A and matrix B. That's going back to the vectors. We're just going to focus on the multiplication aspect of it. Now, we have to remember that this right here is going to be row 1. And we're always going to be multiplying from matrix, the first matrix, whatever one comes first. It can be called A, B, C, or D, but whatever matrix comes first, we're only using the rows, and for matrix B, we're only going to be using the columns. It's always rows by columns. Same way that we define this as a 2 by 2 as a row times a column, same thing. So when I'm looking at this, it's going to be row 1. So it's going to be 1 times 1 times 3 plus, so it's 1 from here, this 3 from this column right here, 7 times 5. So 7 times 5. That's the first element that's going to go in the upper left. This was a 2 by 2 matrix. This is a 2 by 2 matrix. I always check to make sure that these are the same number. It works out, which means the dimensions will work out. And these outside numbers, really kind of cool. The outside numbers are going to give me the dimensions of my solution matrix. This is going to be a 2 by 2, 2 by 2. 1 times 3 is 3, plus 35 is going to equal 38. So in the upper left-hand corner, that's going to give me a 38. Now we're going to get a lot more practice here. It's probably going to be taking several tries really to be getting the hang of this. Now what I'm going to be looking at, I'm still going to be using that first column, but I'm now using row 2. Okay, I'm always going to kind of use the rows, then I'll do the columns. What I'm going to get is I'm going to get a 2. Notice how I'm using this pattern here. This is a 3 and a 5. So once we kind of get in the hang of it, we can start seeing this pattern that will emerge here. Plus, and that's going to be 2 times 3 is 6, plus 15 is 21. Notice how this is going to be row 2. This is column 1. So I'm not looking in row 1, but I'm looking in row 2. That's right below it, column 1. So if we think about this right here, this is row 1 up top. This is row 2 down on the bottom. I'm using information from row 2 and from column 1. So I'm looking at column 1, row 2 right here. So that's where I put my 21. Now we're not actually dividing this using kind of like a cross here. So I'm just going to cross that off. But it is useful. Sorry about that. Just going to try and move this to create a little bit more space. This next one, I'm now going to be using row 1 again, but this time I'm going to be using column 2. So row 1, column 2. So row 1 is going to be 1 and 7. And I'm just doing the spacing because I'm using different colors here. You just need a pencil at home. You're more than welcome to do that. So notice it's 1 times 3, 7 times 2. And I'm always adding them here. 3 plus 14 equals 17. So because I'm using the top row and the second column, I'm going to be top row. Second column here, I'm going to do the same thing. I'm now doing this column. Okay, so it's still second row, second column. So this is going to be second row, the bottom row, second column. It's going to be 2 and 4 times 3 and 2. You might start noticing a pattern that emerges later on, but I'd just like to point that out to you right now. Notice, right here, my 3's are in green, 3 and 5. That means the column is the exact same. It's column 1. Over here, I've made this column 2. So 3, 3, 3 and 2. So 3, 2, 3, 2, 3, 2. You'll notice that in red on the top row, it's 1 and a 7, 1 and a 7. In the bottom row, it's 2 and a 3, 2 and a, 2 and a 4. I made a mistake there. That should be a 4. Nice thing is going back, sometimes you catch your own mistakes. All right. So that's going to be 20 to 26. Give me a 6 plus an 8 equals 14. Okay, that right there is my solution matrix. I'm going to do quite a few of these examples here, just so that you get a feeling for that. Now just to check for understanding here, now notice if we have two different matrices. Now we have matrix C, matrix D. Now it says let F equal C times D. Now the order of these matrices is really important. This means that C comes first, then D. Now we have that written up here as well. Now, this is not going to be a huge emphasis for today, but I'll mention it here for those of you that are feeling pretty good with it so far. This says, remember, it goes rows by columns. This means I'm going to use row 2, row 1, row 2. I'm going to use column 1. That's all it's asking me for. It's asking me to find that element right there. So it's going to be 5 times 1 plus 2 times 3, which is 5 plus 6, which is 11. Now you're wondering right now, why is this not an entire matrix? It's only asking me for one of the elements, what you had talked about last week. This is for the element row 1, column 2 of that matrix. And matrix F is C times D. So I could multiply this entire matrix out, but that's going to be a lot of extra work if you're just looking for one element. Going back from the example that we just had done, if we had wanted row 2, column 1, this is 2 times 3 plus 4 times 5. That's what we have right here. That's number 26. So that right there is, this element right there would be C sub 2 comma 1. Row 1, column, row 2, column 1 of matrix C. Same kind of thing. But again, that's not going to be a huge emphasis here, but it's just something to point out. So for example 1, first and foremost, before you do any work, it can always be beneficial just to write out the dimensions of this. 2 rows by 2 columns, 2 rows by 2 columns. Notice that there's nothing in here, there's no dot saying, hey, multiply. They're written next to each other, and we understand that from our algebra days, that when two things are next to each other, it means multiplication. Always double check. They are the same number right there. That's a 2 and a 2. They have to match up, which means the dimensions here of my solution matrix will be a 2 by 2. Okay. I'm leaving myself enough space to show my work here. And I'll be working in red and blue. So my rows will be red. So this is, remember, the first matrix we always use is going to be rows. The second one is always columns. It always takes a couple examples for students to kind of get this down. So please follow along with me. All right, so it's going to be 0, 2, 0 times 6 plus 2 times 3. I'm not going to simplify all of them. Notice that this is going to be now row 2. So I'm going to set it up. You'll see kind of what's going on here in just a moment. But I'm going to be using, I just did row 1, column 1. Now I'm doing row 2, which has -2 and -5 in it. But I'm still using column 1, which is still a 6 and a 3. And this is where that pattern emerges. This is kind of like a big unsimplified version of what we're going to write up here later on. And then I'm going to be using row 1 again. So over here I'm going to be using row 1, which is 0 and 2. I'm going to be using column 2 now, because this is column 1 right here. This is column 2 over here. This is going to be -6 times 0. And now I have row 2, since I'm bottom row. So this is row 1, row 2. You have a -2, -5. A -6, and 0 again. Remember, I'm going to be adding these. So I multiply the first times the first, second times the second, but I'm adding those numbers together. We did that on the last day before we were out on break when we were doing the dot product. So this right here is an unsimplified version. 0 times 6 is 0, plus 2 times 3 is 6. That's going to give me a -12, subtract 15, 0, plus 0, give me a 12. Right here, -2 times -6 is 12, -5 times 0 is 0. I guess I'll show that work right there. So the answer is, when I get this, I put it right back up here. 0 plus 6 is 6, 0 plus 0 is 0, -12 subtract 15 is -27, and 12 plus 0 is 12. That is our answer then. For this next one, remember, like I said, it's always important to make sure that we list how many rows we have. So this is going to be rows, 3, 3. This is a 3 by 2. There's 2 columns, 1 column, 2 columns. This one right here is 1, 2, 3 rows by 1, 2, 3 columns. This is a 3 by 3. Now, as you're looking at this, 2 and a 3, those are not the same numbers, is undefined. And if you were to try later on, when we learn how to do this in our calculators, there's what we call a dimension mismatch. Okay? Because the columns here do not match up with the rows. Okay? So those numbers are not okay. Undefined dimension mismatch. We cannot do that. But notice when I take a look at this, example 2 and example 3 are the exact same, except the order has been switched in terms of the matrices. This is a 3 by 3, and this is a 3 by 2. Notice, those numbers are now the same. I can have a solution matrix. I can multiply them. My answer is going to be a 3 row by 2 column answer. My answer is going to be a 3 by 2. So I get that. Whatever, the middle ones are always what I check. If those are good, I use the outside ones, and that will tell me the dimensions of my solution matrix. Okay. Now, remember, I always use rows from the first one. And I use columns. That's what I have in this first one. Now, I have 3 rows, so this might make things a little bit faster. And this is, notice, it's going to be a little bit more complex here, because I now have 3 items there. So I have 1, 2, and 3. Oops. I'll go back and looks like I made a small mistake. Each element is going to be multiplied to only one number, but I now have 3 things I'm going to be multiplying. So I have 1, I have 2, and I have 3, and each of those, so 1, 2, and 3 is being multiplied to this row, or this column right here, A, and A. A, A, and A. My next one, very similarly, and I have 3 rows, so I'm going to have to do this 3 times. So first row, second row, third row. My second row, 4, 5, and 6, 7, 8, and 9. Once we start getting used to this, you could start, filling all this out at the very beginning. But you have to kind of start seeing that pattern before this starts making much sense to save time. We have this going on. If I have those numbers there. Now notice this top one is also all row 1, so I'm just going to write 1, 2, 3, 4, 5, 6, because 4, 5, and 6 are from row 2, and then in the third row, 7, 8, 9. I'm just going to start filling in everything from column A, where column 1 is right here. If I'm looking at this as a gigantic matrix, notice this is 1, 2, 3 rows, 1, 2 columns. That's what we have right here. So in column 1, it's always A. Column 2, I'm using B. Everything here. Notice it should go this direction. It's 4 times B, 5 times B, 6 times B. I'm maybe taking this right here, 7 times B, 8 times this B, 9 times this last B. That's how it's going right there. And we can just simplify this. I know that 1A, kind of, this is A, this is 2A, this is 3A. And add this together. 1 plus 2 is 3, plus 3 is 6A. 4A plus 5A plus 6A. That's going to be 10, 15A. 7 plus 8 is 15, plus 9 is 24. Doesn't look like I left myself quite enough space right here, so I'm just going to erase this. And over here, notice this is B's. 1B plus 2B plus 3B's is 6B, 15B, 24B. So notice the numbers are the exact same, it's just the variables that have changed right there. Okay. So that's going to be right here is my answer. Now if the question asks, sorry that was not a great circle, if the question asks what was the dimensions of the solution matrix, it's not asking you to solve, it's just asking you, hey, the answer right here is a 3 rows by 2 columns matrix. It's asking us to multiply it out. Then obviously we have to find all the elements here. So we're going to do 3 more examples. This is from the homework problem set, and then you'll be able to finish it up. Please note at the very end, you'll notice this on the back side of this, that all the answers for 1 through 10 are available. So you can go back through and you can double check all those answers on the attached worksheet. So we're just going to go 1, 2, and 3 together. And I think number 7. Okay, so remember, first thing, always check dimensions 2 by 2 and 2 by 2. Okay, we can do it. And the dimensions for our solution matrix are going to be from this outside, so 2 by 2. I'm going to use rows. By columns. So notice, I know that I have 2 elements. So this is going to let me know that, okay, I'm going to multiply these 2. I'm just going to set this up just to make it a little bit faster for us. And then maybe you can pick up on the pattern yourself. It makes doing this much faster. Do it by hand. So in this first row, I have -5, -5. So -5, -5. I'm taking this top row, and this first column is -2 and 3. For this second row, I have a -1, and I have a 2. Notice how the red are always lining up with each other? It's because I'm always writing the rows by the column. This is going to be column 1, -2 and 3. That is from column 1. Notice that in row 1, I have -5 and -5 that I have up top. In the second row, I have -1 and 2. But for the column, notice it's not -2, 3. That's sometimes a mistake students want to make when they start taking the shortcut. It's -2 and 3. -2 and 3. These numbers should be all the same right here. These should be the same right here. So in this case, -5, -5. Notice all the numbers in row 1, -5 and -5, -5, -5, they will repeat over this way. This one right here is -1 and 2, so it's going to go -1 and 2. When I read it from as a row, -1, 2, -1, 2. When I'm looking at this as a column, I have -2, 3, -2, 3. When I look at this as a column, this is the same, that's the same. Same thing here. There's going to be -3, 5, -3, 5. Now, you might remember when we're in class that I always tell you, once you start feeling like you're understanding it, to work ahead and wait and double check if you got the right answer. So -5 times -2 is +10 plus a -15. This right here, bottom one, is -1 times -2 is 2 plus 6. -5 subtract 3 is going to be a +15 plus a -15. Need to make sure I remember that negative. -1 times -3 is +3 plus 10. 10 plus -15 is going to give me -5. 15 plus -15 is 0. 2 plus 6 is 8. And 3 plus 10 is 13. So -5, 0, 8, and 13. And I'm just going to go over real quick and show you that this, -5, -10, 8, and 13, it works out. It looks like there might be a mistake on the upper right-hand corner. I'm just going to double check that real quick. -5 times -3. -5 times -5. The nice thing, I caught one of my mistakes. -5 times 5 is -25. So even teachers make mistakes sometimes. So that right there is going to give us an answer for -10. And that's our answer for number 1. For number 2, now we haven't seen anything like this before. Now on one of our examples, we had a much larger, we have a 2x3 and a 3x3. This right here though, you can pause it for a moment and see if you can write down the dimensions on your own. This is 2 rows of 1 column. Okay. I'll do that in a different color. This is a 2x1. This is a 1x2. Even though they look really funny, those numbers match up, which means that I can multiply them together, and my solution matrix is going to be a 2x2. It's really kind of weird to think that something that looks so much smaller is going to be the same, larger dimensions. But that's what we're going to end up with. Now, in some ways, this is the easiest one that we will do, but because the dimensions are just so funky looking and not what we might expect, oftentimes this type of problem gives students a little bit more of an issue. Remember rows. Now always do the rows in the first matrix and columns. Now I'm elongating these a little bit more just to remind ourselves that these are rows and columns. So when I do this one, these numbers right here are telling me how many numbers we have to multiply. It's going to give me just 1 and 1, 1 and 1. So in row 1, it's going to be 6 times column 1. So 6 times negative 5. In row 2, we have a negative 3. We're going to have negative 5. In row 1 again, we have 6. Now we're going to be multiplying it to the second column, which is 4. And then we're going to have in row 2, negative 3. And we have 4 in that second column. Once again, notice 6 and 6 is from the top row, negative 3 is in the bottom row. So only negative 3 appears in that bottom row for my first thing that I multiply. In column 1, I have only negative 5s, and in column 2, I only have 4. All I have to do here is I'm multiplying that out. 6 times negative 5 is negative 30. 6 times 4 is 24. Negative 3 times negative 5 is positive 15. Negative 3 times 4 is negative 12. Now it's important that when you write this together that you leave a little bit of space in between these just so it looks like a matrix. You don't want your top line to look like negative 3024. So a little bit of space is always helpful. So when you enter it in on Delta Math, you're feeling all right with that. Example number 3. Now we'll be doing a lot more that look like this in the next week or two. And this is going to be just transformation and rotation of matrices. You did this back in geometry, but now we're able to describe the movement of specific points in the XY field using matrices. Now those of you that are always asking why do we care about this math, this is the math that allows you to have CGI and other things in computer games and graphics of a of an avatar or a character moving around in three-dimensional space. They're using matrices. That is the mathematical underpinning for what they're doing. Okay. So once again, first step. So 2 by 2, and 2 by 2. Okay, those numbers are the same. So what I have here, you get 2 by 2 for my solution matrix. Remember, these middle numbers here in black are going to let me know that when I kind of put this out there, I'm going to have two numbers multiplied together. So I have one set, I have two sets. This is telling me in black right here, I'm going to have two sets of numbers that are multiplying together. There's going to be two sets of numbers multiplied together. Now, I would suggest pausing this and then just seeing if you can fill it out on your own, and then then you can unpause it and you can double check your answer. I'll give you a second to pause. Glad you're back. So hopefully in that intermediate time when you paused it, you wrote in your rows, and so negative 3, 5, negative 3, 5, negative 2, 1, negative 2, 1. My columns here are 1 and 0, 1 and 0. My column 2 over here is going to be 0 and 1, 0 and 1. Okay, so I'm going to simplify this. Negative 3 times 1 is negative 3, plus 5 times 0. The nice thing about this, I forgot, is that 5 times 0 is going to be 0, 1 times 0 is 0. You have a 0, you can just cross that off, and this makes the multiplication that much easier. Negative 3 times 1 is just going to give me negative 3. Negative 2 times 1 is negative 2. 5 times 1 is 5. And 1 times 1 is 1. You'll notice, wait a second, nothing really changed there. Okay? This is a special matrix that we have here. This was an identity matrix, if you remember that from day 1. Okay? So that's the matrix equivalent of multiplying by 1. We're now going to skip to number 7. First off, I'll give you a moment to multiply these together. So you can hit pause and you can get started and work a little bit more on your own. Now hopefully during that break you realize that these numbers are no good together. 2 does not equal 3. They're not the same number. This right here is undefined. And the reason why is because there's a dimension mismatch. So we can't multiply this together. That is your answer. It is undefined. The reason why is it's a dimension mismatch. The columns and the rows do not match up. So think about it again. If you're trying to multiply this by this, 0 times -2, 1 times 3, but then there's no other number to multiply with 5, so we can't multiply that out. It's been lovely kind of leading you through this lesson. Once again, all answers are here at the very last page. If you have questions, please email your teacher. Your assignment is going to be posted on Delta Math this week, so please make sure you have that done. And if you have any questions on that, please email your teacher. If you get any fractions or anything else, which for the most part, I don't believe you should be getting fractions, remember that fraction can be, if you want to rewrite 3/4, you can rewrite that as 3/4. That is the same button that you have associated with the question mark. That's how you can write fractions in, since there are several students that asked that question and emailed me this past week. All right, see you next time.